So now let's briefly look at what happens when we go to monthly. Remember, with the annual annuity, the key was that we ended up summing a geometric summation, and A1 what turned out to be just that regular deposit amount, because that A1 alone is the amount you just deposited. The A1R is the amount you deposited a year ago that's been multiplied by your yearly multiplier little r, which is 1 plus the annual interest rate, and so on. And of course, we don't have to just sum that directly. We have this wonderful shortcut. So here A1 was the regular deposit. It happened to be annual in that case. Okay, but what about everything if everything's going monthly? So more realistic is you deposit stuff monthly. Honestly, you might do it biweekly from a salary deduction or something, but let's say monthly. So you're depositing it monthly and you're getting interest on it monthly. You're compounding monthly. But just like when we looked at monthly compounding, we still said this is like a 5% annual interest rate account. We don't want the frequency of the compounding to get mixed up with how good an account it is. Remember, if somebody said, hey, I'm getting an account with 15% interest, we should just be like, wow, that's really great, and not have to ask, wait, what was the period of that? How does that interact with the compounding? And if somebody has a 12% interest account that's annually 12% interest and thinks because it's monthly they should report it as a 1%, it's going to sound really wimpy. Very similarly, we're going to have our fundamental amount be D, be the annual deposit. So we're going to call that D because we don't want to mix it up with the A1. And then we're just going to separate, we're going to split that up, very much like the monthly compounding story, into 12 different monthly deposits. So I know at the start of a year, I'm eventually going to, over that year, say, deposit $12,000 in this account. That means that $1,000 each month is going to get put into it. Now, of course, the other thing that we already know from compound interest is that when they set their magic multiplier gun to some number a little bit bigger than 1, if they're going to take that annual interest rate, a big R is still the annual interest rate, they divide that by 12 to get the monthly interest, and then it's 1 plus that. So 12 is going to come in those two places. After you do that, it's exactly this same story, because if I'm at some particular time, A1, that's the last month's deposit, and it hasn't got any multiplier. 1 month ago, I put in the same amount A1, a 12th of D, and it got the monthly multiplier R. 2 months ago, I put in A1 and it's gotten multiplied twice, etc. Okay, now the only other thing is I still want to use this exact same formula, A1 to R to the n minus 1 equals this wonderful shortcut formula, but the key thing is n is now sort of how many separate accounts have been opened in that fictional model, or just how many deposits have I done, and that's how many months have elapsed. So that's the other connection here, is that n is the number of months. Well, it's going to be 12 times the number of years. We're going to use what we were always using for the number of years, which was t. And so this is a nice use for t, even though I'm not going to really think of that necessarily as something that can be any real number. It can certainly be any an integer multiple of 1/12 and make a lot of sense here. So this is number of months. So part of what the complexity of the formula we're going to get eventually is just this conversion from yearly stuff to monthly stuff. Once you've done that, it's exactly this guy. Now, if you have it in there for 10 years, that's n is going to be 120. So this is going to be a big summation. That just makes this shortcut all the more valuable. So let's look at it on the Excel side, and we'll try to put in all the stuff. Okay, so here I'm on the monthly tab. So here notice I've got the years going by 12ths and the months going just by integers. I'm taking it out to 100 years just for fun. That's 1200 months to kind of see the maximum value of this. Okay, and so now I've done some of the pre-calculations up here. The key thing again is the $1,200 is what I'm going to budget when I'm planning these investments. I'm going to say annually, what can I afford? $1,200 just to be simple. And then I've got a pre-calculation, that's the monthly. So this guy is D, this guy is A1. Interest rate, we've seen this before. Here's the annual interest rate, a 12th of that is the monthly. So this guy is big R. The multiplier, again, is exactly the little r in a geometric sequence, which we're going to sum. It's 1 plus big R over 12. Okay, and so that's going to allow us to write this formula without too much complexity because we've done 3 pre-calculations to get into the monthly numbers here. Okay, and then it's the same idea. We're just going to be writing down the sum of the geometric summation formula with these key parameters, and we're going to use the month number, or we could use 12 times the year number. They're identical. So let's go back right now, just briefly. We're just going to be putting this formula into Excel. And you'll have this spreadsheet available if you want to use it to check your formulas. I'll make sure that's shared on Canvas. Okay, so it's going to be equals. And so it's that A1, so $C $3 times parentheses, very crucial. And then it's going to be the little r, it's that multiplier, and that's got to have dollar signs too. $H $3 raised to the number of months that this has happened. That's the number of compoundings, that's the number of monthly deposits, and that's going to be B6. Could put a dollar on the B, but I'm not going to worry about it. Definitely can't put a dollar on the 6. Oh, and then, of course, the -1 before the parentheses. Okay, divided by, and then the multiplier -1. So that's, again, $H $3 -1. And we'll see some streamlinings of this when we want to do it by hand and write out the formulas. But this is probably the simplest way to do it. Do those pre-calculations to get it into monthly land, get away from the annual, even though that's how we kind of describe it in the brochure, and put the monthly numbers into the formula. Let's see if it's working for me. So far, so good. Let's see if it works if I shoot all the way down here. 8 million bucks. Okay, this is pretty good. $1,200, just $1,000, a little over $1,000 a year, $1,200 a year, at a pretty reasonable interest rate. I upped it to 6% so that these numbers would be simple for now. And then, of course, I do it for a whole long time. But that's pretty good. 8 million bucks.